Here we consider the interval that goes from z0 to z0.5. And the probability of observing a score in this interval, or using the drone metaphor, the probability that the drone will land in this area between kilometer 0 and kilometer 0.5 is 0.19. And if you consider that the total area under this curve is arbitrarily decided that it is 1, so if the part of the area under the curve that belongs to the interval 0 to 0.5, it's 19% the size of the total area. And we use that as a measure of probability. So probability is 0.19. Now, also remember that this distribution is symmetrical. So that means that from 0 to negative 0.5, the probability for the drone to land in that area is also 0.19. And then we also have that if we add from negative 5 to positive 5, then we add these two probabilities and we've got 0.38. So there is a 0.38 probability that to observe values between negative 0.5 and positive 0.5. Now let's consider the following interval of length 0.5. We go to the interval between 0.5 and 1. There is a 0.15 probability to observe a value in this region. Likewise, between negative 0.5 to negative 1. In the interval between Z1 and 1.5, then there is a 9% or 0.09% probability. And between 1.5 and 2, there is 4% chance of 0.04 probability. In the following, between 2 and 2.5, there is only a 0.02 or 2% probability. And the last one, between 2.5 and 3, there is a 0.005 probability to observe a value in this area. So basically, the intervals that go far away from the center of the distribution are less and less likely to occur. So that's the main characteristic of the normal distribution, is that in the normal distribution the most plausible values are those close to the mean. In this case the mean is 0, so values close to 0 are much more probable than values further away from 0. Until now we provided an interval or several intervals of equal length, and we determined what was the probability of observing a value within that interval. Now we do almost the opposite. We provide intervals of equal probability, and we want to know where that interval is located. So let's examine that. So in this case, we divide the distribution into two parts, and these two parts have equal probability. So we need to divide in two parts that have a probability of 0.5, because the two parts together should add to 1. So we've got the solution. The value that divides the normal distribution into two equally probable parts is 0. Now, a value that divides a distribution in two parts of equal probability is called the median. It's another measure of central location. So we've got another characteristic of this normal distribution, which is the mean is equal to the median, because we said that the median is 0, that the mean is 0, but also the median in this case is 0 as well. And there is another measure that also is 0, which is the mode. The mode is the most probable value, and we see here that 0 is the most probable value. Okay, so let's now divide the distribution into 4 parts. When we divide it into 4 parts, we are looking at quartiles. So here it is. The first interval has to go from negative infinity to somewhere here in the distribution, and that area should be 25% of the total, and therefore the probability of observing a value in that interval is 0.25, a quarter. So we need to identify the value of z that divides the distribution into 25% probability to the left and 75% probability to the right. And that value is negative 0.675. So at this value between negative infinity to negative 0.675, the probability is 0.25. Now, the second value to take into account is 0, because we know that is symmetrical distribution. Therefore, from 0 to negative infinity, there should be 50%. And if 25% is, or we know that 25% is between negative 0.0675 and negative infinity, then we can conclude that between negative 0.675 and 0, there is another 25% probability. And applying symmetry, then we know that from 0 to 0.675, there is another 25% or 0.25 probability, and between 0.675 to infinity, there is the last fourth of the probability distribution. Let's divide now the distribution in 10 equally probable values. So we want partitions in which the probability is 10% or 0.10. These are called deciles. In the previous case, we are talking about quartiles. Quartiles because of 4, and deciles is because of 10. From 0 and 0.25, we've got 10% of the probability. From 0.25 to 0.52, another 10%. From 0.52 to 0.84, another 10%, and so on and so forth.